we have an infinite positive series, real number series, an, and we denote un as an over 1 plus a1 times 1 plus a2, all the way up to 1 plus an. So we want to find out whether this infinite series is convergent or divergent. We don't even know if the series of an is convergent or divergent. Somehow we expect the result to be the same. So while it's not immediately obvious, but I will show you why. This series is actually a telescope series. So the reason is because if I rewrite un as an plus 1 minus 1, it's still the same, over 1 plus a1 times all the way 1 plus an. So therefore I can just first distribute an plus 1 to down here. So this term and this term, they can simplify. 1 over 1 plus a1, this time up to 1 plus an minus 1. That's this previous term. Minus, we distribute this one to this bottom. So 1 plus a1, again, all the way, 1 plus an. Now, here I just denote this whole term as bn. So this term is automatically bn minus 1. That's the only difference. So bn minus 1 minus bn for our own convenience. So before we study this infinite series, let's first study the finite series. I'll denote it as S capital N, that is n from 1 to capital N of un. Right. So when you write it down, it's equal to u1 plus u2 plus u3 all the way up to u capital N. So what is u1? What is u1? u1 is equal to b0 minus b1. But what's b0? Right. So maybe n should start from 2 instead of starting from 1. Because b0 is meaningless. Right? When n equals 1, what's a0? It's undefined. We start from 1. So again, so u1, let's use its original definition. u1, that's a1 over a plus 1 plus a1 up to 1 plus a1. Right? So that's a1 over just 1 plus a1. So u2, we can take advantage of our notation here. So u2 is when n equals 2, that's b1 minus b2. Likewise, u3 is b2 minus b3. Then b3 minus b4 all the way. Right. Before I write last term, so before u capital N, so maybe let's write down u capital N minus 1. Right. Capital N minus 1. N is capital N minus 1. So b capital N minus 2 minus b capital N minus 1. Then last term is u capital N. So b capital N minus 1 minus b capital N. So this time, like I said, it's an obviously it's telescope function series. So we can cancel out these terms. So minus b4 cancel with the next, that is positive b4. This term obviously cancel out with the previous term. Minus bn minus 1 plus bn minus 1. We still have this term. So this time, a1 over 1 plus a1 plus, what's b1? B1 is simple. When n equals 2, we have B1, right? So 1 over 1 plus A1 times all the way up to 1 plus A1. So 1 over 1 plus A1. We have minus B capital N. So that is 1 minus B capital N. Right? But we don't even have to bother working out B capital N, right, which is complex, of course. But this term doesn't matter. It won't play a major role here because immediately, if I get rid of this negative B capital N, because remember, because every AN is positive, and B capital N is, of course, positive. So immediately I loosen the inequality. Right? Imagine if you don't minus this positive term, you become bigger, right? It's bounded above by 1, right? Meaning our finite series is bounded above by 1, right? But because remember, when you have obviously every UN is positive, right? It's a positive series and it's bounded above. So of course, definitely it's convergent.